Have you ever wondered how your internet traffic knows the best way to get from your device to a website across the globe? It is a complex dance of routing decisions, constantly evaluating billions of possible paths to deliver your data quickly and reliably. The autonomous system path, often called a S-path, is a fundamental mechanism border gateway protocol uses to determine the most preferred route for internet traffic. Essentially, BGP looks at the sequence of networks or autonomous systems that a piece of data would traverse to reach its destination. At its core, BGP uses a S-path length as a primary metric for route selection. An autonomous system, or a S, is a large network or group of networks managed by a single administrative entity, such as an internet service provider or a large corporation. Each S is assigned a unique number. When BGP advertises a route, it includes the S numbers of all the autonomous systems it has passed through on its way from the origin. BGP then prefers the path with the shortest AS path length, meaning the route that passes through the fewest distinct autonomous systems. This preference is based on the assumption that fewer AS hops usually translate to a more direct, faster, and often more cost-efficient route, as each hop between ASes can involve agreements and processing overhead. Network operators can actively leverage the AS path attribute for traffic engineering, influencing both inbound and outbound routing decisions. For instance, to make their network appear as a less preferred exit point for traffic, an AS can employ a technique called AS path prepending. This involves intentionally adding its own S number multiple times to the AS path when advertising routes to neighbors. By making their AS path appear artificially longer, they encourage other networks to choose alternative, seemingly shorter paths through different autonomous systems. Conversely, to attract more inbound traffic, an AS might try to present the shortest possible AS path to its peers. Beyond just path length, the AS path attribute also plays a crucial role in preventing routing loops, which are circular paths where data endlessly travels without reaching its destination. As BGP is a path vector protocol, it carries a list of S numbers that a route has traversed. If a BGP router receives an update where its own S number is already present in the AS path, it immediately discards that route. This simple yet powerful mechanism ensures the stability and reliability of the Internet's global routing infrastructure. So, by evaluating the AS path, BGP ensures that your data takes an optimal journey across the Internet, choosing efficient and loop-free routes. This sophisticated approach to path selection is what makes the global Internet as interconnected and resilient as it is today, constantly adapting to network changes and maintaining smooth data flow for everyone.
If you love understanding how the web works, like, subscribe, and stay connected with us.